And thank you everybody for joining me for another one of our Sinumerik training sessions. Today we're going to talk about multi-channel machining. So specifically we'll look at it, how we handle it from our side, our control. But first we want to kind of set you up for the technology. Multi-channel is kind of some interesting technology. It's not, I would say, as mainstream as a lot of other traditional milling and turning machine tools would be. So we're going to get a chance to kind of explore what do we mean by multi-channel technology or multi-channel machining, what are some different machine configurations. So we're going to kind of look at the technology from a whole and then show you how we handle it from the Sinumerik platform. And how do we, we'll do some programming examples and whatnot towards the end here. I'm your presenter, Chris Pollock. I have the window up here. Let me make sure that's still, yeah. I'm your presenter here. I manage the Virtual Technical Application Center. Basically, I do a lot of the content development for Siemens and the Sinumerik platform and portfolio on our web-based material. So I'm going to be your cruise director for today for the next hour or so. If you guys ever need to get a hold of me, you can always reach out to me. My contact information is here for you. I would say probably best scenario would be email, but you certainly, if you're in a bind, can also reach out to me on the phone. We do have a couple webinars coming up here. Our next webinar in December is actually going to be with one of our solution providers or partners called Identify 3D. And Identify 3D has a solution that allows you to handle part program security. So if you have an application where you get into like a lot of ITAR type of applications, government applications, or maybe you just have programs that you want to be able to kind of hold a little more securely, whether it's not allowing them to be edited out of the floor, or maybe they can only be run a certain amount of times and then the part program has to automatically expire. They got some great solutions for that. So we're going to get a chance to kind of see their portfolio. And then coming up in January, we're going to go back to taking a look at 4-axis milling, but we're going to look at it from the G-code side of the world. So I've certainly done some shop mill webinars on handling a 4-axis machine. Now we're going to get a chance to kind of see how that's all going to work when you get into the G-code or the program guide side of the world. Now, our content and a lot of the stuff we're doing through the virtual TAC can all be found here on our CNC4U website. As well, all of the webinars that we do, not only do we promote them on the CNC4U website, but we have a whole archive or library of the past webinars. So if you guys are looking for a specific webinar, I would say go to either CNC4U and navigate over to the webinar section, or you can use the direct link on the top of the screen to bring you directly to where the full library of webinars are. Additionally, we do have operation and programming in-person training classes we host at our training facility out in Chicago. So I always like to mention that that's something that you guys can certainly take advantage of. If you go to the CNC4U website, you can go to CNC Training, and you can see the whole list of classes we offer, specifically in Chicago. So these are instructor-led classes. They're multi-day classes, and they are completely free of charge, 100% complimentary. So if you guys can make it out, we'd love you to work with us on some of these topics. So check it out. There's a whole list of different programs or different courses that we offer, all based around the Sinumerik control. And you can register right there on the website. So today we're going to be talking and looking at our two primary controls. That would be the 828 and the 840. So both can actually be used in this topic. I would say certainly the most popular control platform for this multi-channel machining that we're going to be talking about would be the 840, but the 828 actually has some capabilities with it as well. So you notice down in red, we're talking about how many channels we support. And we're going to explain more about what do we mean by a channel. But that's really how many different programs can be running simultaneously. And it's a direct result of the complexity of the machine. So an 828 can run 2 channels. And the machine example we're going to do today is based around a 2-channel machine. So those examples we're going to show you can absolutely be done on an 828 control. But when you get to the 840, you can go up to 30 channels. So it certainly gives you a lot more capability. And I would definitely say that the 840 is probably the much more popular control platform as OEMs get into this more complex topic. So as I mentioned, we're going to kind of take a look at the technology here. We're going to talk about what multi-channel machining is. I want to give you some examples of some different machine configurations, and then we're going to get into how do we handle it from a programming and a setup and an operations scenario or topic. I do always like to maybe reference some material that you guys can look at if you're more interested in digging into this topic in more detail. So if you go to our industry portal, that's the supportindustry.siemens.com website, and you do a search for the Turning Operating Manual, or you can use that part number I have to the right of the screen, that's that 6FC number. You can bring up this manual, and this manual here, the operating manual, has a full section specific to multi-channel turning. So a lot of the stuff I'm going to talk about today is all supported inside of that manual. So that's a great reference for you guys to start to take a look at and dig in deeper into this technology. Now this seminar, this is actually kind of a continuation of a series of seminars I've been doing on the ShopTurn and turning technology. I've been slowly building up the capability of the control and the system. So I would say this is definitely an addition to the sub-spindle or the counter spindle seminar that I did, but I also did one with B-axis turning. So some of the things I'm going to talk about today, if you haven't seen those previous webinars, I would go back and take a look at them. It'll certainly fill in some gaps. Some of the things, because we are limited in time, I'll have to kind of jump over or glance over, and we delved into them in a much more deeper scenario in some of these earlier webinars. So certainly if you haven't seen it, check out at least the setup and programming of sub-spindle lathes in ShopTurn. I've done ShopTurn with milling and turning technology, B-axis turning, and now we're getting into the multi-channel. And all these things kind of build on top of each other. So what is a multi-channel, or also referred to as a multitasking machine? Well, basically it is a machine tool that can run multiple part programs simultaneously. So traditionally, if we start to look at the machines we see in front of us here, it's generally referred to like an upper and a lower turret style machine. So in each case, each turret is going to move around. That's what we refer to as a channel, or we also like to use the terminology tool carrier, because it's what's carrying our tool. And each of those turrets can be programmed completely independent of each other. Now, they can both work on the same spindle at the same time, or one can be working on one spindle, one can be working on the other. But at the end of the day, you are physically running separate part programs at the same time. So with that being said, how do we handle the program? Well, that's what's in the channel. So the channel is really what's maintaining the program and a specific number of axes. So you start to see that this is probably the most common kinematic setup in the multi-channel world, would be turning multi-spindle lathes, usually with milling type of capabilities. But it doesn't stop there. So when we get to multi-channel, we can start to incorporate all kinds of different technology. So the machine on my left, well, that is really like a 5-axis table kinematic mill that also has full turning capabilities to the left side. So it has a spindle there, a turning spindle, and a traditional turret, and then it has a double rotary table. So they've kind of combined a full 5-axis mill and a lathe into one machine. That's actually a Chiron, and we're going to see a video of how the thing moves around in a second here. But the other area that's starting to get really popular with multi-channel machining and multi-channel handling is integrating robots or work handling. So normally or traditionally, when I was going to deal with a robot, I would have to have a whole separate robot controller driving that robot around. And usually the most interaction I would get between the machine tool control and the robot would just be some simple I/O and simple M-code handshaking, telling the robot when to go and when to stop. Well, that gets pretty limited because all I can ever do is kind of pick and place, and I'm always waiting for the robot. The other challenge is certainly the programming language is totally different than what the machinist or the operator is used to from the machine tool side. So what we've done is we've incorporated the ability of programming a robot right in the Sinumerik control. It's what we call Run My Robot. And it becomes a second channel. Now, we can use that to then obviously do pick and place operations. So we can use it for loading and unloading, but we never have to worry about going to a robotic controller. It's all handled as a second channel in the Sinumerik. But once you have synchronization between the robot, now we can start to make the robot do a lot more. So there's an add-on feature we call Run My Robot Machining, which you're seeing here, where we can actually have the robot do machining tasks if I put a spindle in the robot hand. The other thing is we can do motion simultaneously with the other channel. So I could have the robot tracking or chasing my tool or my part. You could potentially be unloading one vise while the machine's cutting another vise, although both vices are sitting on the same slide or the same table. The robot could be tracking. So there's all kinds of stuff we can do leveraging this multi-channel technology. But for us, let's slow it down a little bit and let's just start to get into the technology in a little more traditional environment. So the video we're going to run here, this is just kind of getting your head around what the machine motion would be, especially if you've never seen one of these types of machines move around. Now, I apologize. I know the video is a little jerky on your end, just kind of the limitations of the tool that I have here. But you can start to see we have a milling spindle. Now, this machine is a little more complex than what we're going to look at because it has a full milling spindle up top. But that's really our first channel or our first tool carrier. And that allows me to start doing work on either of those two spindles, the main spindle or the counter spindle. And then I see more of a traditional turret working on the bottom of the screen or towards the sub-spindle or counter spindle area. Now, what's neat about these channels is they're completely independent of each other, but they can be timed together. So I could have the two channels working on separate operations like I see here, and obviously just streamlining processes. I can have one channel jump to the other spindle. So here, for whatever reasons, tooling configurations or whatnot, we decided to let the lower turret do the drilling on the main spindle. And now we're going to come in with the upper milling spindle or upper turret, which we're going to refer to it as, and start to do more work. So you can get really versatile, and it gives you a lot of configurations or capabilities when you're moving around and methodizing or processing a part. Here we're doing tasks simultaneously on the same spindle. We can obviously be handling tool changes and other back-end operations on, let's say, our first channel or our upper turret, while the other channel is doing more work. So certainly getting a lot more proficiency, a lot more speed out of our process because we can start to multitask like this. And we all love that word, multitasking, right? It's a big ring word in the industries today. So what you're seeing here, I would say this is probably usually your step one when you get into a multi-channel style machine, would be this upper turret, lower turret type of configuration, main spindle, sub-spindle. So the machine we're looking at here, this would be a two-channel machine. They may add a third channel to it for possibly work handling. That's pretty common, whether it's a robot or just like a little shuttle that can come over and pull parts out of the machine. Okay, so now the next video I wanted to show you real quick is a little more complex machine. So we were talking about that Chiron machine, that machine where it combined a mill and a lathe. I mean, this really starts to show off kind of the power of the Sinumerik control. So here we're methodizing a basic part, but showing you how I can move my processes. Now this video happened to be also promoting what we call our digital twin, where we can have a full digital simulation of the machine tool happening as to what's happening or mimicking what's going to happen in the real world. I really liked it because it got to show you some of the capabilities of the multi-channel. So you see on the machine screen there, we have it kind of broken it down with almost like there's two separate controls running, and those are what we refer to as our channels. So here I can jump around and do milling operations on my turning spindle, or then we can maybe transfer the part over into more of our traditional trunnion style kinematic and get into more 4+1 or 5-axis machining operations. So generally speaking, you're going to kind of fit the app, the machine tool a little bit more to your application. I would say if you're looking for something, if you're a job shop and you want something more versatile, you're probably going to look at more of that traditional upper turret, lower turret configuration. I would be probably the most adaptable to any standard machining processes. Okay, so what are our pros? What are our cons? Just to set up a few here. Certainly, the pro is reduced cycle time. I mean, you can start to see how I can do multiple operations all simultaneously, all with the same control, all in the same controlled work environment. If you're going to be moving into unattended operation, lights out machining like we referred to it, this type of technology is very adaptable and easy to set up and get running completely unmanned and automated. We can reduce the work handling, right? I can now transfer things between the main spindle, sub spindle, but I can do a lot of operations that maybe I would have had to necessarily do as secondary ops. And certainly the more we pull that part out, the more we physically touch it and interface with it from a human perspective, we can incur error, we can incur inaccuracy in the part. So it's certainly helping us there, which obviously is going to increase the entire proficiency of our process. Now, these are not cheap machines by any means. There's a lot of technology, there's a lot of axes going on. But if you look at it from the comparison of if I was going to go out and buy a machining center and a turning center, well, what would the cost of those two products be? It's actually not as far off when you get into a multi-channel machine as you might think. Because if you think about it, you're combining those two machines. So you have the same number of axes, same number of spindles. There's a lot of stuff that it's there. It's in whether it's two separate machine tools sitting on your floor or combined into one. Now, historically, the programming is quite complicated, obviously, when you get to this type of technology. And that's why we're going to show you ShopTurn and some of the functionality we've built into the control. From the programming and the setup, I think we've added some pretty unique features and functions to at least help streamline and simplify that side of applying this type of technology. Okay, so let's get into the meat, right? Let's start to talk about how's the machine designed, what's it really going to look like. So first things first, everything still works from a fixed datum. So whether we have two separate channels and two separate tool carriers or turrets moving around in space, they all need to know where they are in relation to one specific fixed datum. So it doesn't matter how many channels you start to get. The datum of the machine, where everything's referenced from, is always going to be a constant. And in this case, on a traditional twin turret style machine, you're going to see the machine datum, the machine 0, is going to be the face of the main spindle. And all offsets are going to build from there. So when you're first kind of getting your head around these machines, the simplest thing is to know where's my reference, where's my machine datum, and then I can start to see how all my offsets start to stack from there. And then it's really just a matter of managing how many axes you have and what the manufacturer kind of called the axes from a terminology standpoint. So our example, we're going to be looking at a machine that looks very similar to the picture you see right here on the right, an upper and lower turret. Our machine is going to have y-axes in both turrets, so it's a pretty complex machine tool. But the machine we saw in the video is more closely resembling the machine we see on the left. So that would be a lower turret and an upper milling spindle. So when you start to look at this, you want to kind of get your head around, well, what axes are assigned to what channel? Because anything I do in that channel, from a part program standpoint, is going to drive those axes. So a lot of times channel 1 would usually be the upper turret. Doesn't have to be. So you certainly would need to know what axes are assigned to that channel. And in this case, the second channel is going to be the lower turret. Now the spindles are interesting because they'll be assigned to a specific channel, but they transcend channels. So you're going to be jumping from either spindle, running either spindle, as far as the work holding spindles are concerned, from either of your two channels. So don't get caught up on the fact that the main spindle is in channel 1. That doesn't mean that channel 2 can't run the main spindle. So the only time they're separate is what's unique to the turret or the work holding, the physical tool carrier. So here is the layout of our machine. Now, each builder does it a little differently as far as how we're starting to name our different spindles. This machine is loosely laid out on an example of a DMG CTX style lathe. So for them, what they like to do is they always use the same spindle terminology no matter what complexity of the machine tool. So what that means is the live tool on my upper turret is always going to refer to a spindle 1 or C1, depending on if I'm in a positioning mode or if I'm in a velocity mode where I'm running it for more of a cutting type of operation, right? I'm spinning an end mill. That would be like a velocity mode. I'm positioning something. That would be more of an axis mode. So that's where we have the C or the S, depending on the mode you're in. But in their case, S1 is always the upper tool. S2 is always going to refer to the lower turret and the spindle in the lower turret. Now, if you buy a machine from them and it only has one turret, well, that's going to be referred to S1. My main and my sub spindle is always S3, main spindle is always S4. So it's kind of like a T, right? It's or you're making almost like this, kind of like the sign of the cross, a little bit inverted, but upper, lower, sub spindle, main spindle. So maybe you buy a very simple main spindle and one single turret machine from DMG. Well, they're going to call their main spindle always S4. This way they have consistency in the product. Each builder will do it a little differently. Again, make yourself a little cheat sheet. I always like to make myself a layout of the axes and the spindles. Just give myself what the terminology is. So this way, as I start to write the programs, it's real easy to kind of keep track of which spindle is called what. Okay, so we have our spindles, our 4 spindles. Now we have our physical axes. So my upper turret, which is channel 1, is going to be X1, Y1, Z1 as far as the machine configuration is concerned. Now when it comes to part programming, I'm always going to just call them X, Y, Z. So when I go to program, I don't have to worry about the X1, Y1, Z1 or any difference in terminology. They're assigned to be X, Y, Z. Now when I get to the lower turret, you see how they're X2, Y2, Z2? Again, that's from a machine configuration perspective, but from programming, they're just X, Y, Z because the 2 channels are separate. So I can have 2 X's in this style machine, and as long as each X is assigned to a different channel, I don't have to worry about calling them a different terminology. And what I'm referring to is like, see the Z3? Z3 is what drives my counter spindle or my sub spindle. That's the Z axis that's moving the sub spindle. Well, since the Z axis, the Z3, happens to be actually in the same assigned channel as Z1, when I program it, I must refer to Z3. Because if I just called it Z, the system wouldn't know which Z axis I'm talking about. So if you're bouncing between channels and you have 2 X's in each of the 2 channels, you don't have to worry about all these different terminology as far as which X axis I'm telling you. You would just call it the X of that channel. It's only when you have multiple axes in the same channel that we have to have a differentiator. So what is the screen going to look like? How is it going to change a little bit? Well, I'm going to start to see my channels. Now, certainly when I have my machine display selected, I will see whatever the terminology that was used by the OEM to designate the channel. And when you hit the actual values machines to look at the work coordinate system, if you see the display switch to just read X, Y, Z, that means in that channel you can address that axis as simply X, Y, Z whenever we're programming it. Now take a look at the spindles. This is important. So I am currently looking at just channel 1. You see how we have 3 spindles listed? But in the previous slide, I just showed you there's 4 spindles on this machine. Well, this is only going to show you the live tool spindle, the spindle that's on the turret, for that specific channel. Right? There's never a reason for me to try to drive my spindle that's part of channel 2, or my turret number 2, my lower turret, from the first channel. But I do want to be able to run either of the 2 main spindles, right? The main spindle or the counter spindle. So that's why you have the S3 and the S4 in channel 1. As we transition to channel 2, you'll see that I have S2 now becomes active. I can start to program and work with S2 because that's the milling spindle or the live tool spindle on the lower turret. But I still can see S3 and S4. and I can program them. I can interface with them. Because again, those work holding spindles, they transcend the channels. So even though they were assigned to channel 1, that doesn't really matter. You're going to be able to run them from either of the 2 channels. You just won't see or won't be able to affect the spindle that is specific to that channel, which would be the spindle that's on the tool carrier. Tool carrier being our turret. So we launched the machine, we're in the machine, we're at the machine. Our screen's going to look a little different. You have 2 separate controls, or 3 or 4, depending on how many channels you have, active at this point in time. So you literally see each of these 2 controls as channels. So if I'm looking at the screen, you see where it says in the upper left-hand corner of the screen, channel 1 in yellow, and it says reset to the next side of it because it's in a reset state. Well, that's what's telling me not only which channel I'm showing you at that point, but which channel is active currently. So there's a couple new buttons I got to get used to because I'm going to bounce between the channels when I have specific operations that I may want to have happen at one channel and not the other, or just see different feedback. Now, you can turn things on or off. So we're going to look at that here, where I can maybe just show one channel at a time because I don't want to see the other channel. I'm just concentrating on setting up the one channel. Well, that's okay. We give you a couple different additional settings like you see here on the right. Under settings, there's a new button called multi-channel functions that you're going to get. And then you can toggle which channels you want off or on. And if you have more channels, you're just going to see you can toggle between those additional channels right here in this section. So the key commands you want to get used to, or the additional command, is the group or channel button. Right? And that button, you're going to have to find it on your machine control panel. My panel that we're showing you here that we're going to look at in Sinutrain happens to position that button just to the left of our blue keypad or arrow keypad. That's the button that's going to flip me from channel 1 to any of my other channels. So I just toggle it. I hit it once, it goes to the next channel. I hit it again, it's going to move to the next channel. If it only has 2 channels, it'll just bounce back and forth between the 2 channels. Now, once I'm in the channel, I may need to navigate through the windows. So that's where you use the next window button. And that's a button that people might be a little bit more familiar with, because certainly we use that button in lower technology. But really between the 2 is kind of how you're going to navigate around. Now, if you're lucky enough to be on a machine with touch screens, you can just touch the channel area and it'll jump between the 2 channels. But if you're on a machine that does not have any type of touch screen, you have to use that channel or the groups button. And that's what's going to bounce you back and forth. And then we can go into MDI and take a look at the MDI. Why don't we take a look at Jog first before we flip into MDI, because I do want to show you kind of how this looks. So I'm going to bring up Sinutrain. Sinutrain's our machine emulator. I use this obviously for a lot of our demos, but this is going to show us what's happening on the machine. So right now, if I look at it, I see that channel 2 is yellow. So again, now that's the active channel. So depending on what I do, it's going to happen to that channel. If I want to move that little yellow indicator and change the channel that I'm going to be interfacing with, I find this group channel button. Again, remember, it's just to the left of the number pad. And as I hit it, you're going to see my highlight moves back and forth between my 2 channels. Now, we gave you that settings function. So if I expand my horizontal keys over and go to the settings button, there's this new button called multi-channel functions. And here I can toggle different channels on or off if I have multiples. I can select whether I want 1 channel or 2 channels. And what's going to happen here, whether I do it with the checkboxes or do it with this field, it's going to be the same result. But as I back up, you're going to notice that now I'm only seeing 1 channel at a time. Now I can still use the group command to toggle between my 2 channels, right? So we see how the channel 1, channel 2. So maybe I have an operator that's a little intimidated by everything that's going on the screen. Well, or maybe I have a smaller screen, it's hard to see some of the stuff. You might want to use this type of mode. It's really kind of up to you. You're customizing it on your own. And then you can flip it back, right? It's just a setting. So here I'm going to go back to 2 channels. And we'll pop back to it. So why am I doing this? What does this mean for me? Okay. Well, we have a bunch of keys along the bottom of the screen, right? And those of us that have use the Sinumerik control at all know that the TSM allows me to do tool changes or start a spindle, or maybe I want to set a tool length offset. Well, we didn't want to have duplicate buttons for each of the two channels. So the TSM button is only going to currently affect the active channel. So if I want to change the tool on my upper turret, right, I got a CNMG 432 loaded right now in the upper turret. I simply hit TSM. I come down to my name. This is going to work the way it works on any of our machines. I pick a different tool I want a tool change to. I say OK, cycle start, and now it changed the tool for channel 1, but didn't do anything to channel 2. If I want to change channel 2, then I would toggle over with the channel button and do the same thing. So that's really why we have that. So now any of these commands that I go into, if I want to just position around a specific channel or location, I can jump into it, right? So here I can use the position key, and the X I would program now would be affecting channel 1. If I flip over, I can now do an X command to channel 2. That's all it is. Okay, so that's the start of kind of getting your head around these two different channels or these two different turrets. So in our case, left of the control, this is my upper turret. Right, channel 2 is going to be my lower turret. Okay. We additionally have MDI. Now, MDI is going to show you both channels as well. And I can start to implement different instructions. But what you have to kind of pay attention to when you start to use MDI on a multi-channel machine is that when I hit cycle start, there's only one cycle start. And it's not going to cycle start just channel 1. Remember, the whole beauty of this control is I can be driving both programs simultaneously. So what's going to happen is if I put a command in MDI and I hit cycle start, well, it's actually going to run both MDIs. So you may or may not want that behavior to happen. So we do give you a couple different ways to affect how MDI is going to function. And this is similar to how I would treat it in Auto 2 if I didn't want both channels running at the same time. So one of the things you could simply do is have just a basic M30 in one of the two channels. And if there's no other information, then if you hit a cycle start, it just executes an M30. So that would let the one channel just do what it's doing. But we've also added a new function under program control called run in. And run in is going to give you that little pop-up you see on the right side. And here I can now, with the checkboxes, turn on or off what I want to happen based on my program in front of you. So if I only have channel 1 checked, then anything I do, whatever's in the MDI of channel 2, it's not going to do that. So let's take a quick look at that, because that's important. So we jump over to MDI, like I normally would in any control. And here we see I just have a quick SUPA command in both of my channels. This is just sending me to a safe retract location. And I see I'm sitting at some value other than those locations. Now, if I was to hit cycle start right now, both of these would execute. However, I may not want both of these to execute. So I got a couple options. One of the things I could easily do, if let's say I only wanted channel 1 to run, is put an M30 in channel 2. And maybe I'll send this machine just to go something different. We'll go to 25. So I hit cycle start right now. I see the machine move. Now, this is a position independent of my offsets, right? Because it's a SUPA command. So if I toggled it to the machine coordinate, I would see that it went to that location. More importantly, though, you noticed this channel didn't move. Now, it had no bearing on this button. I hit cycle start, and it's running both of these at the same time. But channel 2 had an M30, so nothing happened. So now let's say I get rid of the M30, right? And I'm going to send her to somewhere else just so we see it move. But maybe I want to do the exact same behavior, but I don't want to have to edit the MDI section on channel 2. Just go to Program Control, select Run In, and you get this little checkbox window. So now I decheck channel 2, and that's just saying, hey, channel 2 is in a PRT mode. See, it's program test mode, access lock, right? So you see how I check it? That's really how we're doing it. I can inhibit my spindle. So if I was asking a spindle to do something and I want to suppress it, we could do that. But just by checking or unchecking a combination of these two buttons, the machine will move to some other location, but this one's still never executed. Now, if I want both of them to run, because I'm going to send them both to a safety retract at the same time, make sure everything's checked, hit cycle start. Both have now moved to this desired location. If I go to actual values, I'll see the numbers match based on where I drove it from MDI, because I was just using a super command. So that's important, because the last thing certainly you would want to do is start moving around a turret when you weren't expecting to. That's when bad things start to happen. Okay. So now that we started looking at kind of how we move our machine around a little bit, some of the unique functions that came up when this type of technology, now let's look at how the system builds. Now, we're going to have to do the same steps we did in that earlier webinar, which is describing our work holding. And it's probably even more important when you get to this type of technology, because you got a lot of stuff going on. You now have two separate turrets, channels, programs, all addressing the same offsets. So I would strongly suggest adopting this type of method. So in our settings data screen under spindle chuck data, we're going to want to go in and define the work holding, whatever it happens to be. So my example, we happen to have two identical chucks, one on the main, one on the counter spindle. So my dimensions of the chucks are the same. So I got a 3.5 inch body with a 2 inch projection. I did that for both. I did it to keep the numbers simple. Real world, yes, there are going to be some differences in the work holding, and you want to reflect that. So you want to make sure you have some good measurements on knowing where the chucks, where the chuck is, what there are, and the dimensions are always going to be relative to the spindle, right? The spindle gauge, or where that chuck mounts. So that's your datum. So we're going to go in, we're going to go to the spindle chuck data, and we're going to describe it here. Now, the next step is kind of getting your head around where you have for travel and where are safe locations. So I would strongly suggest making a little drawing like this. I usually always just do a quick hand sketch, lay out my work holding, take a look at what my total travel is for each channel. It's going to be different. A lot of times the lower turret, just based on the nature of the configuration of the machine, has less travel, especially in the X, than the upper turret does. So you want to make yourself a nice little cheat sheet. On the sheet, you want to say exactly how much travel you have, what's the axis designations, right? And where do I want to park the subspindle? So all of these kind of play in conjunction with each other. Then the next step is figuring out my work offsets. Now, yes, you can go and you can measure the work offsets like you would in a normal lathe, but since I know everything from a specific datum, it's very easy to calculate. How far out do I want my part sticking out of my work holding? Well, that's my work offset. So in this case, my 8.450, that's what's going to be in my, if it's a G54 or 58 or whichever work order I'm using, that's the value that's going to be there for my first work coordinate. Now, second work coordinate, that's going to address my counter spindle or my sub spindle. So there, I kind of do the same thing. Now, it's all working off that main gauge line or main machine data. That's why it's so important for you to understand where it is. And here, if we look at it, now this value is going to vary based on where I park my subspindle. Remember, on this machine, this type of machine we're using, the main spindle is fixed. Subspindle moves back and forth with the Z3 axis. We looked at that briefly before. So the work offset's dependent on that location. So you want to kind of pick a park area where you're going to send that subspindle. So it's going to be held during all of the machining ops. So this way, it means that that work coordinate for the Z-axis on my second work offset, which will treat my sub, is going to be a constant. You start moving around your park position of the subspindle, you'll have to adapt for that. You have to compensate for that in the work offset. So set up your layout, and then you can start applying it. Now, how is this going to work in the physical work coordinate screens? It's going to work just like it did before on the simpler machine that had just a basic subspindle. But here, you're going to notice that you're going to have parallel values in the second channel axis. So you see how we have X, Y, Z, and then we have the Z2 further down. So you're going to want to make sure you reflect the same offset in both channel 1 and channel 2. So the work coordinate, it's not specific to a channel. Even though it says channel 1 there, that's just a representation of the channel that's on. But the work coordinates are one of those things that transcend between the channels, because that work coordinate's active all the time. Remember, I can bounce or I can move my lower turret between my two spindles. So channel 2 can work on G54 if that's on my main spindle, or G55 if that's my sub. Now the G55, I still want to use the mirror command, and the mirror is going to allow me to have all negative offsets towards the part. So it's mirroring the z-axis. But again, the work coordinate's the same. So you notice you have a z value in the z-axis and the z2 axis. That's a constant. Depending on how the builder commissions it, it'll actually automatically fill out that value for you. So our control is set up that way. So before we start the part program, let's take a look at the offset table, because I do want to show you that area, because that is a little different. So we're going to go to offsets like we normally would, and here's the work coordinate section. So again, this is just like you saw, very straightforward. It's going to look the same way. This channel tag doesn't mean anything, right? The offsets transcend the channels. But what this does mean is when I look at my tool list or my toolware or my magazine button, so you only see one channel at a time as far as the tool makeup is concerned. So in here, the channel button is very important, because as I toggle it and I go to channel 2 or tool carrier number 2, this is going to show me how the tools are configured for the lower turret. And in fact, even look at the display. This is an OD turning tool. So you see how it's pointed towards the top? If I go to group of channel 1, well, that's an upper turret. This is an OD turning tool as well, but it's pointed towards the bottom. So even the symbol is going to represent how it sits in the machine, and we're going to invert that as I start to build different tools for these different channels. Just keep in mind where you're at here when you're looking at it. You're just going to toggle between the groups button to look at either turret. But that's how your offset table. And that's identical to running a simple 2-axis lathe. Okay, let's get into a little part programming as we're moving right along. So the intention here is to just kind of get you opened up to this technology. So in this case, I didn't want to do anything over complicated. We're just going to do a simple little turn. The process is what's key. So what we're going to do is we're going to face off, and we're going to be running this part that's sitting in the main spindle and the sub spindle simultaneously. So we're going to get to do a little bit of turning on the main spindle with our upper turret, and then I'm going to do a little bit of turning at the same time on my counter spindle with the lower turret. And then we're going to jump around a little bit. I'm even going to take the lower turret and drill on the main spindle just so you can see us moving around. So this will be the part that we're going to part program. I'm going to stay there. So we're going to go in and we're going to start to write programs. So this is going to all look the same as you've done up till now. The only difference is if you're one of those guys that likes to write your programs in the part program or subprogramming area, you're going to want to get used to putting everything in work pieces. Everything's going to build inside folders. And the reason being is because there's a new function called program sync. As long as you have it activated, and it is an option, but generally speaking, you're going to see this activated on machines with this technology, but that's the option number right there. I gave you that 6FC number. But as long as you have the program sync option, you're actually going to create what we call a job list. And this is where things change, and this has to be done in the workpiece folder. So when you go to methodize a new job, go to your workpiece folder, create a new unique folder, and then you're going to build the job list first. Once you build the job list, you're going to start to see how that starts to make the part programs. So come in, give it any kind of name you want. Same naming terminology applies. Once you've said OK to the name, in this case I'm using sample 1, then the system's going to automatically do this pop-up, the job list, and the .job file manager, basically. You're going to see however many channels you have in that machine. So if you have multiple channels, more than 2, you're going to see them right now. And now you're defining what the part program names are and the type of part program for each channel. So if you had already previously posted out what these files are, yes, you can use a file that you've already posted or named. They can be G-code, they can be ShopTurn. You can intermix the two. The empty options there, if maybe you wanted to run this machine as a single channel, you could have the extra channel just be an empty program and nothing would be there. And then once you do this, you give it the name. Now it's going to autofill the name based on the job list. You could change it if you want, but there's really no point. So normally what I would say is just use your job list as whatever you would want to call that part. And then the _1, _2 is going to reflect channel 1, channel 2, because they are physically two separate part programs. You say, okay, you're going to come in, fill out a page that looks very similar to your normal header page, but it's actually a piece of the header page. Then from there, you're going to have a secondary header page for each unique channel. So we're going to see as we go in that we have to make sure we fill out the rest of the data for channel 1 and channel 2. And that's what you're seeing here. So the left side would be channel 1, the right side would be channel 2. And then I'm going to tell it kind of what's happening right now for this data. So we're going to go through, we're going to fill out that page. And then you're going to come in and you're going to see the editor. And the editor is going to look a little bit different than you're used to because you're now viewing or looking at both part programs simultaneously. From here, we can then start to add in some of the other functions. So once we've created this, and we've created that first header page, I'll show you how this whole thing navigates in a second. Then we're going to go in and just make sure that each of our sub-header pages specific to the two channels are set up properly. And this is where we handle the safety retract location, the tool change point. And you notice that in each channel, I can address each spindle because I can bounce between either spindle. So if you don't fill out that spindle for that channel, then if you go to try to program that spindle, it's going to come back and give you an alarm. So you've certainly got to tell it the information. It just allows you a little more flexibility. You can use different retract locations on maybe the main spindle than you do on your counter spindle, your sub spindle. So these get built for you, but you do always want to open them up and make sure that the numbers themselves make sense. So we're going to jump through channel 1, and then we're going to take a look at channel 2. So let's transition and let's build our part program. So go over to Program Manager. You want to make sure you're in the Workpiece folder. And now we're going to create a new folder. So I'm just going to do that like I would create a new job. I want to be on directory. And I'm going to call this Sam1 for sample 1. Or we call it anything we want it, right? Now remember, this file name here is going to be most likely used in the job file and then later used in the part program. So pick something that makes sense for the job. So we created our first folder, and now the system assumes that you're probably going to want to create something else. So it now gives you the ability of creating a part program, or you get the new program sync button. This is the new feature that you're getting with a multi-channel machine. So yes, I want to do a program sync. I'm going to call it the same name. That's fine. Select OK, and now you're going to see the subscreen. And that was the subscreen that I was showing you before. So here it used the name of the job file and just added an _1 or an _2 to reflect channel 1 or channel 2. We pick the type of program we're doing. In our case, we're doing a simple ShopTurn program. I say OK, and we're launched. So this is setting up our multi-channel data header. So there's not all the information here. This is what's setting up our work coordinates that we're going to use between our main and sub spindle, our physical work offsets, right? So remember earlier we went through and we kind of figured out the layout of the machine, right? We figured out and calculated that the work offset is going to be 8.450. Now I can set that just normally in the offset table, or I can write to it. So when you get to this more complex technology, the last thing you want to do is have an operator maybe step on an offset and then everything goes haywire, right? So here, if you know that your work holding is not changing and your part location is not changing, write it from the work coordinate system. And what this value will do is that number right there is going to write over whatever's in the work offset table. So in case somebody made an error, that's going to write it over. If you say no, then it's going to use whatever's in the work offset. So that's the only difference there. Set up your blank like you normally would do. Now here, my jaw type, I can describe it inside the program, or I can use just that settings screen. So earlier we had looked at the settings screen, especially earlier in the other webinar. I showed you a slide on it here. Well, maybe that's the same scenario as my work offset. Maybe I want to make sure that somebody didn't put a wrong number there. So this will overwrite that offset table. So in fact, the numbers you see here will then become the numbers in that offset table once you run this program. So we set up our main spindle and our counter spindle, set up our offsets we know we want to use. So I'm using 54, 55. What work offsets I'm pushing into it. But you notice I don't have any safety retracts. The only thing I'm going to tell it here is the park location for the sub spindle. The other stuff is going to come in later in the header pages for each discrete channel. So we say accept, and now you're in the editor. And it automatically opens up both programs because it knows we're building a multi-channel program. So the information you just filled out is up here in the multi-channel data. So if you want to get back to that page, just move your cursor up to this first event. And the reason it's so long is because it affects both channels. It affects both part programs. Blue arrow to the right, and there's that page, the first page we filled out. Now I move my cursor over, and I can open up the second header that's specific to just this channel. And remember, channel 1 is the upper turret. So all this is saying is that upper turret, these are the retract values I want that upper turret to use. This is this tool change position I want that upper turret to use when I'm working on the main spindle. Now, if I had common values between all, I could say, hey, do the same thing, whether I'm on main or counter. I could do just the counter, and then this could be the main. I mean, it really doesn't matter the order you give it. But this is just telling it what I want to happen when I'm working on the main spindle with this turret, this upper turret, this channel 1. Where do I go to tool change? Then what do I want to do in the lower turret? Safety distance. Other than that, if you've done any programming in ShopTurn, these are all the same variables. That's the beauty of the Siemens control. We always talk about how I can start with a lower technology and get into the upper. It's because we keep everything as consistent as we possibly can. Okay, now to jump over to this channel, right, to open up this other header, that's also where I would use this group button. Right? That's also what toggles me back and forth. Now I got a mouse. Maybe you're on a machine with a touchscreen. You can also just touch the screen. Makes it easier. But if you don't have a touchscreen or a mouse, then you got to use that button. You come in, and now we're doing the exact same things, but now for the lower turret. So if you notice from the drawing I had before, I'm using a little different retract location because maybe my lower turret doesn't have as much travel as my upper, or maybe I need to position in a slightly different Z location. That's why we've given you the ability of kind of separating and breaking up all this. But everything in this header, it's specific to the lower turret or channel tool too. Okay, so that's the start of your program. That's how everything starts to get going here. So now as we move in, we're going to start to write a program. So we're going to write a program using simple little events. But the first thing now we have to talk about is how do I tell it that I want my upper turret to work on my main spindle or to work on my sub spindle, right? If I go into the cycle, there's no differentiating where that turret is going, what spindle it's going to work on. And remember, both upper or lower turret can move between either of those two main and sub spindles. They can work on the same one at the same time, different ones at different times. So you do that through groups. So if you've ever seen groups in a lower level technology, it's just a quick way of kind of putting a bunch of events together and expanding and contracting them. There's not a whole lot of sophistication to groups there. The groups really came from this technology. And what this does is now in the group, we can tell the machine, hey, I want to now do everything I'm going to do on my main spindle, or I want to do everything I want to do on my counter spindle or my sub spindle. So any events that are in that group are going to go to whatever spindle you called out. So this is the big trick right here. You got to use groups when you start to do this stuff. So for our little example, we're just going to do a face and a turn on the main spindle. We'll then come back, do a face and a turn on our counter spindle. And then we'll start to talk about some new features in simulation, right? We give some new niceties when you start to work between these different channels. And we're going to continue to move on in complexity. So let's start to put some of these first things into our tool path, right? Now, it doesn't really matter which channel I start with. It's kind of up to me. I want to put my highlight on the header because I'm inserting below. But I do want to be in the edit screen because I got to go to build groups. And build groups is what's going to get me access to this. So here I start to see that there's a few more options in the group window. There's only a couple things I absolutely need. First thing, I got to give it some type of label or name. So I usually like to refer, like to operations, right? My turning up, my facing up. So you can get as elaborate or as simple as you want. I'm just going to call mine op1, and I'm going to call it upper T just for my own, my own recognition of upper turret. And I'll call it LT for lower turret, we'll say. Now this is where I decide what spindle I want that channel to be working on at this moment in time. So I'm going to go to the main spindle. This is where the cheat sheet comes in real nice and handy. In case you forget that S4 is your main spindle, you look down your little reference sheet and you grab it. There's a couple extra OEM commands we can put in here. The other one you want to pay attention to is the retract, the automatic retract. Now this will send the machine to the retract, the tool change location you defined in the header. Since we're already there, it really makes no difference right now. But later in the program, that might be very critical. So pay attention, especially if I'm jumping between operations with the same tool and I don't have a tool change being affected, then there may be no reason for the machine to have gone to the tool change location between going to a new operation. So that's when you can use this automatic retract. If you're at all worried about it, just use it as yes. It's not going to hurt you. Select accept, and now you have a group. Now you do have to expand the group. So if you hit the blue arrow over, you'll see it expands the group, because if I leave it compressed and I go in to do an operation, right, I'm going to go do a simple little facing op. So I'll come in, I'm going to fill out my facing geometry, right, start at 4 and at 50,000. If you guys want to see the print, I can bring it up real quick. All right, so we're just going to face off this side real fast. Now, what's cool here is since I know that I'm in channel 1, I entered this screen while inside of channel 1. When I hit select tool, it's only going to show me the tool changer for channel 1, for upper turret. Even if I go all the way to tool list, I can start to build my tools, but I'm just in that one. When I do it from channel 2, it's going to just show me that tool changer. So we grab an OD tool, we fill out the page. Now you see how it inserted the event below the group? Well, that's a problem. I need it to be inside the group. So that's why you want to make sure the group is open when you create it. So in my case, I'm just going to copy and paste. We'll cut it, drop it in here. So that's where you want the events to be inside the group. Okay, so we got our first op. Now let's go back. We're going to turn this hub down, right? So I'm just going to use a simple stock removal. I happen to have left it with our dimensions and our chamfers. You guys at this point certainly should know how to program the cycles. If you don't, take a look at my earlier seminars. But here we have 2 events. So at this point, this is now going to run on this left-hand side, or this spindle. If I want to jump over and put my additional operations, I can do that now. So here, we come over to the header page. I would normally move over with the group button or use your mouse. We want to go over to groups, so go to edit, build group. Now, I'm still doing op1 now on the channel 2 program, so I can call it op1. But I might want to have, again, a little bit of a differentiator for my own sake. So I'm going to say, hey, anything happen here, this is my lower turret. Now, where do I want to send that lower turret? Well, I'm going to let that one run on my counter spindle, spindle 3. Let it go to retract, that's fine. Hit accept. All right. Remember to expand it. Let's go pick whatever our tool path's going to be. In our case, we're going to do a simple little face. Now, see, we do select tool. It automatically picked the tools for the lower turret. So I'm going to select OK. I fill out my speeds and feeds, leaving it some defaults, obviously. And now we're going to do this little contour. So I did this one with the churn, with the tapered. That's how I'm getting that taper in, a couple of those fillets, right? Okay. So we got some toolpath in. So let's simulate it and let's see what it's going to look like. So we jump over to simulation, and now you got a couple extra features. Now this is going to look similar to the main spindle sub-spindle area, right? So I have my 2 buttons, but now the difference here is I can see 2 physical tools running simultaneously. So that's what's really happening. Now, since I have 2 channels moving around, you see how I'm only seeing the tool path on the one area? Well, that's because it's only going to show you in simulation the tool path for whatever channel is active in simulation. So although both are running simultaneously, I can toggle by using my lower expansion key for my vertical soft keys. I can toggle between my 2 channels here. So that's what just allows us to flip around between channel 1 or channel 2 when I'm simulating. They're both running at the same time, so it doesn't matter what mode I'm in as far as that's concerned. Right? I rerun it, I come over, see, they're both running. I can just toggle between them. That's just going to map my show path function. You can look them in 3D, right? So I can go into a 3D. They can be running simultaneously in 3D. So you get a lot of control here. Now, the other thing I really like to do is a lot of times I may not want to look, and I'm just going to go to a side view, at both channels like this because I want to see what the machine envelope looks like a little more. So I may just leave the main active, but zoom back all the way. So that's just a zoom window. The other spindle exists. It's there. So if you want to see both kind of as it would from the perspective of if I was looking in a window at the machine, I could also run it here and see both channels running simultaneously. There I see the sub-spindle go to its park position. Again, if I want to flip the show path back and forth, I do need to use the little channel button. So not a ton of stuff here, but enough to certainly make it a lot easier to kind of move back and forth between the channels with the simulation. But the beauty here is we're obviously seeing both operations simultaneously. So you can kind of gauge timing and how things are going to start to work on the system. Let's go back to our slides. Okay, so we put a couple of operations in. Now, what happens when I start to put operations that there's dependency? So my next op is drilling a hole. All right. Now, if I just go to drill a hole and I don't put any timing markers in, what can happen is that potentially I could be sending the lower turret to a spindle where the upper turret's working, and if I have clearance issues, I could collide with them. So what we did was we added a bunch of different what we call wait commands. I would say the most common, and you're first getting used to this, you're going to play around with the wait M command. And that's just telling it, hey, I want you to not do anything until the other channel catches up with me. And once they catch up, now I can move on to the next operation. So this is how we start to use wait commands. So I'm going to show you how to put one in. And first I want to show you what would happen if we didn't use it, and then we'll apply and we'll add a wait command. But there's a bunch of different ones here, and there's little nuances between them. Certainly the difference between wait M and wait C is with or without exact stop. But just to get started, let's concentrate on the wait M command. So that's our first wait code we're going to look at. Okay, so what I wanted to do on this part, so if I look at this part, I got a hole. I got a 1-inch hole. I'm going to punch through it. And I'm going to do that while she's sitting in the main spindle for any number of reasons. But for my fixturing, my tooling, my configuration, I happen to want to use the lower turret to do that. So I want my lower turret to run over and go cut on my main spindle. So right now, I can certainly, now when you go to build the next group, watch this. See how it says remove group? If I have groups back to back, just compress the previous group and that'll give you the build group option. If I don't, if I leave it open, I highlight here and hit remove group, it'll delete the group. So just be careful of that. Okay. So I'm going to build my next group. This is going to be op2, right? And this is going to be lower turret. I could even tell it what op2 is containing, drilling, or whatever. And I'm going to drive it over to my main spindle. And make sure she's at a safe spot or retract. That's fine. So I put in my op2, right? And now we're going to tell it to go drill a hole. So I'm just going to use a basic drilling centric. I'm saying that I'm not worried about using a live tool. Fill out my drill, whatnot. It's going to pick turret number 2 or lower turret, right? Because it knows that that's the channel I'm in. So make sure I have that tool selected. Hit accept. So at this point, if we first simulate this, let's take a look at what's going to happen. And we'll go to details. We'll do a quick auto zoom and I'll show you both so you get a little better perspective, okay? So we're coming through, we're turning. Now, it just happens that these two channels have about the same material to remove. So everything looks good, right? I would think that everything happened, that I didn't run into any collisions. But in reality, what happened if I had more material volume to remove on channel 1 or my upper turret? Or maybe I was running it a lot slower. See, currently there's nothing in the system that says, I want you to wait for channel 1 to be finished. So maybe here we just put in a real super slow feed rate, right? So that channel is going to take a lot longer to run than the other channel. Now what you're going to see because you're going to see that we're going to go try to attempt to drill a hole while it's still turning. Now maybe that's okay, and that could be okay. You're going to know based on your machine, your configuration, whether or not I could fit that drill in there while she's turning, and maybe that's a way for you to get more proficiency out of the system. But more likely than not, you just crashed the machine. So this is where the wait commands come in. So what you're going to want to do is you're going to have parallel wait commands between each channel. So basically you're going to say, below the group, it can be inside a group. I usually have mine outside the group myself, so I can always see my wait commands so they don't get collapsed inside of operations. But what I'm going to do is I'm going to go to various, I'm going to expand over, and I'm going to see a wait marker button. And the wait marker gets me to this screen. Now, by default, we allow you to create up to 99 wait markers or wait statements in a given part program. I believe there's an MD associated with that, so I believe you can increase it. Generally speaking, anything I've done, 99 was more than enough. But usually what I'm going to do is I'm going to start with the number 1. And I'm right now telling it, well, what channel do I want to wait for? Now, I can't set it up to just wait for itself. I mean, that makes no sense, right? It obviously has to wait for itself. So you're going to have to at least tell it to wait for the other channel. Now, you could tell it to not wait for itself. It doesn't make any difference. It's got to finish itself. But simplicity's sake, a lot of times I would just leave them both at yes. The ability of toggling these yes or no really becomes important when I have a lot of channels going on, right? Maybe I have 3 or 4 channels. Then I can toggle which ones I want it to wait for, which ones I don't want it to wait for, right? But in this case, it's a simple 2-channel lathe, so generally I would just leave them both at yes. I hit accept. And now the trigger between the 2 paths, right, I want it to wait till after it gets done with this turning op before I let it drill. So you want to make sure you use the same wait number. That's what sets up the timing between the 2. So just accept it. And now you have these 2 different wait markers. And what it's saying now is that when I run, I'm going to have to make sure that both channels complete to the point of that wait marker before I'll let either channel move to the next operation. So we see return. Now we see how much longer channel 1's taking to machine our part. It finishes it up. Simulation might kick it up a little bit. That's just simulation. But you see how now it waited till it was done turning before it let the drill come in. Okay. So that's how wait channels start to work. So as we start to push more into the different operations, you can start to kind of build the system. Okay, so we got a little bit more that we're going to do. I want to do a transfer because it's important to see how to do a part transfer when we get to a multi-channel part program. So let's jump over to that. So the next operation is part transfer, and this is going to look, 99% the exact same way we did the earlier seminar, as far as all the triggers and all the features or functions that I would need to do within the cycle. The difference, however, is there's now a synchronize command you have to put in the opposing channel. So you see how on the right side we have right here it says counter spindle synchronize? You don't have to do anything more than just go in and say, where do I want the other channel to sit and wait while it's doing the transfer. Now it'll work with the main transfer cycle in either channel. I tend to put it in channel 1, specifically whatever channel has my main spindle and counter spindle addressed in, but it really makes no difference. You can put them in either or they'll run either way. So usually what I'll do, like I said, is I'll put my counter spindle, my actual transfer cycle in my channel 1, and then my synchronize, that's just going to sit in channel 2. Now I want to make sure that I add a wait command from the drilling perspective before it starts to transfer, because the last thing I want to do is try to have that sub spindle come in and grab that part while I'm still in the middle of drilling it. So let's go add that. So before we get started, go to the bottom of the group. Here we're going to go back to various and to wait. Now I can't duplicate the number. I need to be using a new number here, right, for my next wait statement. And I want to put the parallel to that on the next side. So I go into wait markers, accept it for number 2. And that's just going to make sure that the drilling completes before I do the part transfer. So we're going to go to various as well, back up to the counter spindle cycle, just like we used in a basic lathe. We'd fill out the same thing. So here, the only difference is because I'm putting the cycle into channel 1, this location, this is where I'm parking the upper turret. Certainly I want to tell it what's happening in the lower turret, or the second work coordinate for the subspindle. I want to park it in the same position. And here we could drive the work coordinate value in, but we already did it in the header page, if you remember, so it really doesn't make any difference. I may need to do it here, though, if I was parking her at a new location than I had it before. So that's, if you had a scenario where I wanted to, for some reason, send the subspindle to a new location when it's done with the transfer, then I'm probably going to need a different work coordinate value because they're all dependent on that. So you fill out your cycle, and I had to put the second wait command here, not only to align the two, but because I wanted this channel to wait until the drilling was done before it moved on. But you do need to make sure you come over to channel 2, go to counter spindle again, and just up here, you want to pick the synchronize option. And there's a bunch of different things you could do here. You can do gripping and drawing, but we're just doing a simple pick and place. So you go to synchronize, tell it where now I want the lower turret to position, and just hit accept. So it's a matter of doing that. Now, this isn't so much as a necessity, but I do see a lot of people do it, and I guess it kind of makes sense. A lot of times you'll see in these multi-channel machines a final wait command at the very bottom of the program just to make sure everything is done before one channel ends, right? Kind of waits for both channels to fully be done doing whatever they're doing before they both hit the end of program and everything shuts down. So with that, I'm probably going to add a final wait marker. And generally what I'll do is I'll just use 99 or my highest number. This way I can insert wait markers wherever I want if I'm adding features in the program and I know I don't have to worry about updating this lower one. All right, so now I have my two final wait commands. If we go to simulate, now we're going to see the entire part kind of methodized as a whole. So we got our turning, we have our slowed down channel 1, so we're going to have to wait for channel 1 to finish before we'll let channel 2 go over to main spindle. Then our turret would come over, or our subspindle would come over. Obviously, I would have some kind of unload process prior to the subspindle coming over, grabbing the next part. Usually that's where I would have either an automated shuttle or maybe an operator has to go in and pull the part out of the subspindle before she comes back. So there's a program stop and a command comes up. But the process, hopefully now you start to see. And then we could issue a bar load or something along those lines if we had a bar feeder. But these are the steps. This is really kind of all you have to do to start working with these multi-channel machines. So we've really kind of leveraged a lot of functionality here and shoved it into something as simple as ShopTurn. So I find that it makes it a lot less intimidating kind of moving into this technology. Now, one thing that's nice when I'm looking at a program, especially when I get to more complex programs, is to see how they kind of align with the wait commands. And you can also have it kind of show you how the cycle times stack. There's a bunch of different things you can do. So under the edit, the other thing you're going to see that's new when you get to this multi-channel machine technology is a synchronization view button. And that's going to align the two programs. So back here in our little part program, you see how the wait commands are kind of not directly aligned. So it makes it a little more difficult to read, right? I got to know that, okay, I'm going to be waiting here for just this portion of the program, especially as I expand and contract things, So under the edit button, expand over, go to view, up in the top right corner, and click on synchronize view. And you'll see it moves things around. It didn't change anything, hasn't edited anything. If I take it back off, it's going to look the same. But what it does is it kind of aligns it for me. And as I expand and contract things, it's just going to keep that aligned. So I see, okay, everything that's happening up top is happening at the same time. And nothing else will happen until I get to this wait command. I can quickly see that channel 2 is the only thing that's running at this point in time because I have a big blank spot in channel 1 right now because I didn't tell channel 1 to do anything. And then I get to the next wait command and I see my counter spindle and the synchronized mode are at the same time, and then everything ends. Okay. So the last thing I wanted to show you guys real quick, just to give you a quick representation of how it's going to look, is the auto screen. So we do want to take a quick transition to the auto screen before we kind of open up to, I'm sure, a ton of questions from your side. So auto is going to look very similar to Jog or MDI. So I'm going to see both channels if I want to look at both channels. So I can certainly toggle them on or off. And then I can start to run things. So if we transition back, when it comes time to run a program, process is going to be similar. So I'm in this editor, this job editor, right? This multi-channel editor. I'm just going to hit execute. It's going to bring me over into the part programs. Reset rewinds both channels at the same time. Cycle start starts both channels, just like in MDI. So then they start running, and I start to see the machine moving around. I can certainly bring up simultaneous record. You would see the simulation just like we saw in the run screen. Now we see that we're only running channel 1 because channel 2 is waiting on channel 1, so I'm sitting at the wait marker. Once it catches up, we're going to see that we're going to go drill with channel 2, and channel 1 is going to be sitting waiting for channel 2 to now do something, right? So we'll come through. Maybe we'll give it a little more override. All right. We drilled our hole, did our transfer, and everything's done. So just like you saw in MDI, I can go in, I have the run in command. So if for any reason I wanted to suppress portions of the program, maybe I'm proving out just the upper turret, and I don't want to run the lower turret section at that time, I can deselect them. You're going to use that. Other than that, everything's going to really be very similar. Now, I can toggle between my program times. I can use my group channel to move between them. So maybe it's something like I'm using the overstore button. Well, that's where I would need the group command to jump into overstore, let's say, if I needed to. So that's where you'll still bounce between the two channels. So we try to keep everything as consistent as possible. But that's it. Now we're starting to run. So certainly we've covered a lot of material here. With that being said, I want to bring up my contact information again, and I want to open this up to you guys now. I'm sure you got some questions. So use either the chat window or the Q&A window to type in your questions, and we can start going through them. Let me start looking. I see we do have a few in here now, so let me take a quick read. Okay, so actually Joseph was asking, he was saying that it's probably a little advanced for this session, but he understands we can do pinch turning. And yes, I'm glad you brought up pinch turning. I'm actually going to be doing a webinar that'll be the next one to this one that talks about pinch turning in detail. But what Joseph is referring to when we talk about pinch turning is the ability or the capability of using the upper and the lower turret to turn on the same spindle at the same time. And then you'd have a lead and a follow scenario. So that, yes, the system can handle it in ShopTurn or in G-code. So when I go into, and I can actually be in the same program I was in. Let's say we were down here and I was going to do a turning cycle. So when you get to contour turning, as long as you have the option for pinch turning, and it is an option, you're going to get, and I might not have it turned on this machine. I don't think I do. No, I don't think I have it turned on. But there's an option to activate pinch turning. Certainly, if you have immediate questions on it, reach out to me. I have a couple little videos I think I put together on the topic. But additionally, I'm going to be doing a webinar on that in the not so distant future. It's going to be, there's a couple webinars in between it, but we will be talking about pinch turning. Pretty cool function because it allows me to lead and follow that tool. So back to your initial question, I kind of gave you the long answer, but yes, you can do pinch turning in ShopTurn or in G-code. Okay, so let's take a look at some of the other questions we have. Oh, can you save tool setup data on a multi-channel machine? So what I think this came from Joe. What I think Joe is referring to is a lot of guys like to use in Program Manager the function under Archive called Save Setup Data. And what that does is that's going to create a little file that's a backup of our tool table and potentially all our offsets, right? So it makes this little program, this INI file. Now, it works the same way here, but what you want to watch out for is it's going to create this file and specifically the tool information relative to whatever channel is active. So if I don't have that channel active, I'm actually only getting a partial. So what you're going to want to do is you're going to want to build two. One might be for channel 1, and then use your group button to toggle it. Go back into archive, say setup data again, maybe change our name slightly, call it 2 or whatever, doesn't really matter. And now I have the same file, and then I can read it in and it'll rebuild for those specific channels. Now the offsets themselves, since they transcend, they'll just get rewritten. So they'll look identical, it's just the tool data. Okay, let's see, what else do we have here? Can I run the machine as a single channel machine? So yes, and you know that's probably not a bad idea when you're first kind of getting into this technology. You want to kind of move into it a little slowly, right? So maybe I just want to run it as if it was just an upper turret for a little while. So there's a couple ways to do that. So remember when we were building this program, right? We were doing our multi-sync, and I'm just going to call mine test 1, 1, 2, 3. I did have the option of doing an empty. So I'm building it, but there's really no file there. So that's one way I could handle doing that. But the other thing I could do is, let's say I was going to do my whole program in conversational, but I said, no, the other channel is going to be in G code. One of the other ways I cheat this, all right, let's get back to the editor. Oh, of course, now my PC slows down. But the other way to kind of cheat that would be to add an M30 and only an M30 in the G code program that's sitting in channel 2. And then both load, and when I hit cycle start, it's just going to let channel 2 hit the M30, and she's just going to sit there. You can do that, or the final option would be, remember how we could select the channels in the run screen. Let me see, is she back up behaving? Yes, she is. Oh, I hadn't hit accept. Let's go back to run. I could also use this button right here to deselect that channel. So you got a couple different ways you can do it. I usually always did the trick where I had whatever channel I didn't want running, I just made a low part program and had an M30 or an end of program. And then without anything else being there, it's just not going to do anything. It's just going to sit. Or maybe send it to a safe location. That's probably a little better. Send the turret to a safe location just in case it got moved somewhere, and then have an M30 after that, and she'll just sit there. But yes, you can certainly run this machine without having the other turret. You can just leave it parked and then treat it as a single channel machine. Okay, and I don't know. I don't think I missed any, but if I did, I know we're kind of running low on time. But if I missed anything, by all means, feel free to reach out to me. You guys have my contact information, and let me put it up here one last time. I want to thank everybody for taking time out of your busy days to join me. Hopefully you found this topic interesting. Certainly I do. It's a pretty cool technology, and certainly it can be a viable step in the process of your shop and your proficiency. So if you have any other questions, please feel free to reach out. Thanks again for everybody attending, and take a look for the video. I'll be sending you guys a link as it goes live. All right. Thanks a lot.